Hello everybody and welcome back to the virtual revision class of Network and Cybersecurity 15EC835. Today let us revise module 3 of a syllabus which is IP security. Now the contents of this module are as follows. First we have IP security overview, then IP security policy, encapsulating security payload, next combining security associations, and finally we have internet key exchange. To begin with, let us first understand the meaning of IP security. So, the Internet Protocol Security or IP security is nothing but a secure network protocol suite that authenticates and encrypts the packets of data to provide secure encrypted communication between the two computers over an IP network. In simple words, it is basically a protocol suite which provides secure communication between two computers over a particular network. Now, to achieve this, the Internet community has developed a range of application-specific security mechanisms, the examples being S-MIME, PGP, Kerberos, SSL or HTTPS, which we have already seen in the previous module. Now, the advantage of implementing security at the IP level is that an organization can ensure networking not only for applications that have security mechanisms but also for many security ignorant applications. So for this reason, IP security is really important to be implemented. Next we have the applications of IPSec. So firstly, IPSec provides the capability to secure communications across a LAN or a local area network, across private and public WANs or wide area networks, and across the internet. So these are the networks where IPsec provides secure communications if it is implemented. However, the examples of its use include secure branch office connectivity over the internet, next, secure remote access over the internet, establishing extranet and intranet connectivity with partners, and enhancing electronic commerce security. So these are the examples. Coming to the IP security scenario, as you can see in this figure, the LANs are distributed over the network, and at the Ethernet switch, the packets travel without any security, and then there is a network device or networking device having IPsec. Now if we look at this figure, what this IPsec networking device does is, it typically encrypts and compresses all traffic going into the WAN and decrypts and decompresses traffic coming from the WAN. To repeat, the IPsec networking device typically encrypts and compresses the traffic going into the WAN and decrypts and decompresses the traffic coming outside the WAN or coming out from the WAN. Now these operations are transparent to workstations and servers on the LAN, that is local area network. So as the packet goes out of networking device, an additional header called IPsec header is added to it. Here, one thing you need to remember is that IPsec provides security in headers only. And so, we will be discussing authentication header, that is AH, and encapsulating security payload, that is ESP header. Similarly, a user system can also have IPsec implemented into it, and it can go to the public network, and there again we will have networking device with IPsec implemented. So this kind of secure transmission is also possible with individual users who dial into the WAN, that is wide area network. So after the operation, let us now move towards the benefits of IPsec. Now, when IPsec is implemented in a firewall or router, it provides strong security to all the traffic crossing the perimeter as we saw in the previous figure. However, when implemented in a firewall or router, IPSec is resistant to bypass. That is, if all traffic from the outside and entering organization is using IP and the firewall is the only means of entrance from the internet to the organization. Next, now since it is below the transport layer, hence it is transparent to applications. That is, there is no need to change the software on a user or server system when IPsec is implemented in the firewall or router. Next, even if IPsec is implemented in end systems, the upper layer software including the applications is not affected. Finally, it can be transparent to end users, that is, there is no need to train the users on security mechanisms, issue keying material on a peer user basis, or revoke keying material when users leave the organization. Next we have the IP security documents. Now this IPsec that we have been talking about encompasses three functional areas, namely authentication, confidentiality, and key management. Now these documents can be characterized or categorized into the following groups, that is architecture, authentication header, encapsulating security payload or ESP, Internet Key Exchange or IKE, cryptographic algorithms, and several others. Now let us look into each in detail. So firstly, moving towards the architecture. Now this basically covers the general concepts, security requirements, definitions, and mechanisms which define the IPsec technology. Next, the authentication header is nothing but an extension header to provide message authentication. Then we have encapsulating security payload or ESP, which basically consists of an encapsulating header and trailer, which is used to provide encryption or combined encryption along with authentication. Lastly, the Internet Key Exchange or IKE is a collection of documents which describes the key management schemes for the use with IPsec. We also have something called as the cryptographic algorithms, which consists of a large set of documents that define and describe cryptographic algorithms for encryption, message authentication, pseudorandom functions, and cryptographic key exchange. Apart from all this, we also have a variety of other IPsec related RFCs, including those dealing with the security policy and management information base or MIB content. Then there are some services which are provided by IPsec. So here it is. The IPsec provides security services at the IP layer by enabling a system to select required security protocols, determine the algorithms to use for the services, and put in place any cryptographic keys which are required to provide the requested services. So the services include access control, connectionless integrity, data origin authentication, rejection of replayed packets, which is nothing but a form of partial sequence integrity. Then we have confidentiality or encryption, and lastly, limited traffic flow confidentiality. So these are the services which are provided by IPsec. Next we have IP security policy, and in that first we shall have a look at security associations. Now the security association is a one-way relationship between a sender and a receiver that affords or provides security services to the traffic carried on it. I repeat, security association is nothing but a one-way relationship between a sender and a receiver that provides security services to the traffic carried on the association. Then the security association that we have been talking about is uniquely identified by three parameters, namely security parameters index, which is also called as SPI, next IP destination address, and security protocol identifier. Now the security parameters index or SPI is nothing but a bit string which is assigned to the SA and having local significance. Now the SPI is carried in AH or authentication header and ESP headers in order to enable the receiving system to select the SA or security association under which a received packet will be processed. The next parameter is IP destination address. So here currently only unicast addresses are allowed, and this is the address of the destination endpoint of the security association, which may be an end user system or a network system such as a firewall or router. Then the third and final parameter is security protocol identifier, which indicates whether the association is an AH or ESP security association. Next we have the security association parameters. So the security association is normally defined by the following parameters, namely the sequence number counter, which is a 32-bit value used to generate the sequence number field in AH or ESP headers. Then the next parameter is sequence counter overflow, which is nothing but a flag indicating whether overflow of the sequence number counter could generate an auditable event and prevent further transmission of packets on this SA. Then there is anti-replay window, which is used to determine whether an inbound AH or ESP packet is a replay or not. Then we have AH information, which consists of the authentication algorithm, keys, key lifetimes, and related parameters being used with AH. Then we also have ESP information, which is nothing but encryption and authentication algorithm, keys, initialization values or IVs, key lifetimes and related parameters being used with ESP. So this is similar to the AH information except for with which it is used. In that case, it is used with AH and here it is used with ESP. Then we have something called as lifetime of the security association, which is nothing but a time interval or byte count after which an SA must be replaced with a new SA or terminated. Plus, this is also an indication of which of these actions should occur. Next is IPSec protocol mode, which can be either the tunnel mode, transport mode, or wildcard mode. Then there is path MTU parameter, which consists of any observed path, maximum transmission unit, and aging variables. Then we come towards security association selectors. In that, first we have remote IP address. Now this remote IP address may be a single IP address or a range of addresses, or it can also be a wildcard address, which is called as a mask address. Now the latter two are required to support more than one destination system sharing the same SA or security association. Then you have local IP address. Now this may be a single IP address, again an enumerated list or range of addresses, or a wildcard address. Now the latter two are required to support more than one source system sharing the same SA. So the remote IP address supports destination address and the local IP address needs to support the source system. Then you have the next layer protocol, which is nothing but the IP protocol header, which can be either IPv4, v6 or v6 extension, and this includes a field that designates the protocol operating over IP. The next selector is the name, which is a user identifier from the operating system. This is not a field in the IP or upper layer headers, but it is available if IPSec is running on the same operating system as the user. Then there is local and remote ports. Now these may be individual TCP or UDP port values, an enumerated list of ports, or a wildcard port. Next we have IP traffic processing. Now IPSec is executed on a packet by packet basis. When IPSec is implemented, each outbound IP packet is processed by the IPSec logic before transmission, and each inbound packet is processed by the IPSec logic after reception and before passing the packet contents to the next higher layer, that is to the TCP or to the UDP layer. I repeat, when this IPSec protocol is implemented, the outbound packet is processed before transmission and each inbound packet is processed after the reception and before passing it to the next higher level. Now this figure 20.3 highlights the main elements of IPSec processing for outbound traffic and figure 20.4 highlights the main elements of IPSec processing for inbound traffic. Let us see the operation with the help of the flowchart in detail now. Let us see the processing for outbound IP packet now. So firstly, the IPSec searches the SPD for a match to its packet. Next, if no match is found, then the packet is discarded and an error message is generated, as you can see towards the left. However, if a match is found, then further processing is determined by the first matching entry in the SPD. So next is we have to determine the policy. So if the policy for this packet is discard, then the packet is discarded. If the policy is bypassed, then there is no further IP processing and the packet is forwarded to the network for transmission. There is another possibility that the policy can be protect. So in that case, if the policy is protect, then a search is made of the SPD for a matching entry. If no entry is found, then IKE is invoked to create an essay with the appropriate keys and an entry is made in the essay. Now this matching entry in the SAD determines the processing for this packet. After that, either encryption, authentication or both can be performed and either transport or tunnel mode can be used. So then the packet is then forwarded to the network for transmission. Next we have inbound processing. So here an incoming IP packet triggers the IPSec processing and then the following steps occur. Firstly, the IPSec determines whether this is an unsecured IP packet or the one that has ESP or AH headers or trailers. And how does it do it? It does that by examining the IP protocol field IPv4 or the next header field which is IPv6. After the check is done, if the packet is unsecured, then IPSec searches the SPD for a match to its packet. So if the first matching entry has a policy of bypass, the IP header is processed and stripped off and the packet body is delivered to the next higher layer such as TCP or UDP. However, if the first matching entry has a policy of protect or discard, or if there is no matching entry at all, then the packet is discarded. Now the third step that occurs is for a secured packet, the IPSec searches the SAD. Here again, if no match is found, the packet is discarded. Otherwise, the IPSec applies the appropriate ESP or AH processing. Then the IP header is processed and stripped off and the packet body is delivered to the next higher layer such as TCP or UDP. So here all you need to remember is the number of checks that have been performed at each step and what happens if the check is true or false. I'll stop here today. We shall continue in the next class. Thank you.